I welcome you guys to another video session on Mat104. Based on the previous video, we actually stopped at question number 18, whereby for question number 19, we have the question as thus, which says a manufacturer's cost function for a good is given to us as CQ. Let me take a pen. Just hold on, please. So we have a manufacturer cost function. The cost function is represented as C of in terms of the quantity demanded, so which is equals to 1000 plus 20q, then plus q root 1 plus q as well. So this question asks us to find the derivative of the cost function with respect to q. So that means we want to differentiate c with respect to this q. So to do that, I will advise you to evaluate this third thing. That should be the first thing you are supposed to do. So if I evaluate that third thing, I should have it as 1000 plus 20q. I don't have any issue with this first and second thing, but I have issue with this third one, whereby I can rewrite this as q, whereby this square root of 1 plus q can still be written as 1 plus q raised to the power of 1 over 2. How is it 1 over 2? If I put this in a bracket, there's an invisible power of 1 here, and there's an invisible 2 here. This is square root of 1 plus q, which implies that by the rule of indices, which is fractional law of indices, fractional index law. Fractional index law says you take the index you have inside, take the fraction of the index you have inside and the one you have outside. Simple as it is. If you have cube root of 1 plus q, then that would be 1 plus q raised to the power of 1 over 3 in that case. So that's how it works. So I believe you understood how this works now. So now let's go ahead and differentiate. To differentiate this particular cost function, that is, we want to differentiate that cost function, which is in terms of q, with respect to what? With respect to q as well. That's been said there. They said find the derivative of the cost function with respect to q, and that will be equals to, if I differentiate this 1000, that will give me 0. And if I differentiate 20 cube, there's an invisible one here. 1 times 20 is 20. Then if you subtract 1 from up here, you have it as q raised to the power of 1 minus 1, and that is q raised to the power of 0. And that will give us 1. So 1 times 20, I'll be left with 20 in that case. So here in this case now, in this third term, I have this as two things multiplying each other. So I can decide to use product rule for this one. I'll let this one represent you and let this represent you. That is product rule. Okay, and product rule simply means, you have two terms multiplying each other. You use the product rule of differentiation, which simply implies that this represents you and this represents v. So you are supposed to use this formula according to product rule. Okay, what does product rule says? It says the derivative of product of a function is actually represented as u and v, such that its derivative will give us uv prime plus vu prime. So that is the formula. So that means in this case now I'm not supposed to write u dot v. I'll just write uv prime plus vu prime. Okay, whereby I'll just take a worksheet here and I'll write out my u represents q. U is the first function, and v is equals to this 1 plus q raised to the power of half. Remember that in our previous video, I actually asked you guys to go and check. I asked you guys to check one of the videos I did for calculus. I explained how to differentiate a function that has any index, whether it is fractional or it is negative, use a negative index or fractional index or positive index. I actually give a pattern for it. But if u is equals to q and v equals to this, u prime will automatically be equals to 1. Because if it differentiates q, now I have q is power of 1 here, that's 1 times the visible 1 here, that's 1. So if I write q raised to the power of 1 minus 1, I will have it as q raised to the power of 0. And q raised to the power of 0, that is 1. 1 times 1, I will still have it as 1. So my u prime is 1. So to solve for v prime will be equals to what? Whenever you have a function inside the bracket and it is being raised to the power of something, right? So to differentiate something of this nature, just take down this power. This power will come down first. This power will come down, write it out, 1 over 2 times. you will now have to differentiate what you have inside this bracket. So if I differentiate what I have inside this bracket, I will have differentiate 1, that is 0, differentiate q, that is 1, right? So that's not all. You still have to multiply it with everything that you have here, which is 1 plus q raised to the power of 1 over 2. But remember to subtract 1. If you go ahead and check one of my videos that I posted on my YouTube, you notice that I've explained something like this. Just go and check it out. Mat102, I think that's the title of the video. Mat102. It's based on calculus. Okay. I explain all these things. So just go ahead and watch it and understand it clearly. So this is v prime is equals to, I'll have this one as 1 over 2 times 1, which is still 1 over 2. Then times this 1 plus q raised to the power. What's 1 over 2 minus 1? That's minus half. You can do that yourself. You get that minus half. So I already have my v prime, my u prime. I know my u and I know my v. So I'll just go ahead and substitute that here. So the derivative of the cost function with respect to the quantity demanded, okay, is now equals to 20 plus, the formula is uv prime plus v prime. So what's my u? U is q, and v prime is what I have as this 1 over 2, 1 plus q raised to the power of minus half, okay, that is uv prime, then plus v u prime. What is v? V is this 1 plus q that we actually have here, which is b raised to the power of half. Then my u prime is 1. So now let's try to check what that will give us. So looking at this now, this is just equals to 20 plus times this, that is plus. I'll have this one as q times 1 over 2. Okay, I can have this as q over 2. Now remember that if I have a negative fractional index, okay, a negative fractional index, that means this negative index implies 1 over. I think I've been explaining it in the previous videos as well. This negative index, this power of minus means 1 over. So I'll be left with just 1 plus q is to the power of half. You know, I've already multiplied this q and half. I have it as q over 2. So I'm left with this. So this power of minus means 1 over. So I'll be left with just 1 plus q raised to the power of half. So I'm trying to give a full explanation to it. That's why I'm doing it step by step. So for this one, I already have this one as just 1 plus q raised to the power. Okay, sorry. I have plus, this is 20 plus times this, I have all this result here. Then plus times plus this third term that I have here, I will have it as 1 plus q is power of half. So my final answer is 20 plus q times 1 is q all over 2 times 1 plus q raised to the power of half, then plus 1 plus q raised to the power of half. So finally this will give us 20 plus q over 2. This 1 plus q is power of half. I can reverse it back by using the law of indices. I think I have a net I have a network issue. Okay, it's back. So 1 plus q, this 1 plus q is power of half, you automatically becomes square root of what? 1 plus q. It's not the same thing. This half represents root. Okay, and this fractional index half also represents root. That's one square root of 1 plus q. So that is option A. 20 plus q over 2 root 1 plus q plus square root of 1 plus q. So this is the correct answer. This one, there is no q up here, which is wrong. So option A is correct. So this is how it works. So let's quickly move straight to the next question. So I believe in the previous video, I think I've actually done solution to 20. I've solved 20. We've answered 20 together. So we've answered 21 together as well. And as well, we've answered 22 together as well. But we've not answered question number 23. So let's please solve question number 23. So for question number 23, let me take a pen for that. So let's quickly consider question number 23, which says if you have x raised to the power of 3 plus 3x, I don't know why this network is fluctuating, plus 3x, connection is still restoring, just take it please. What's going on with this network? This network is very, very poor. Very, very poor. I have to use the app. Can't record the app. So I have plus 3x. What is question? 3x y squared. Then minus 2y to the power of 3 equals to 3. Then what is dy dx? Looking at this question here, if I want to find dy dx, so I have to differentiate each of these term with respect to x individually. Differentiate this x cube, this first term with respect to x, plus also you need to differentiate this 3xy squared with respect to x as well. At the same time, minus you need to differentiate this 2y raised to the power of 3 with respect to x as well. And then you differentiate this 3 with respect to x also. Okay, so you have d dx of s cube, d dx of this, d dx of what I have there. Okay, so for you to differentiate each and every one of them, so let me write this clearly. So let me write this very well. So this is the best way to write it. D dx of x is to the power of 3 plus d dx of 3xy squared minus d dx of 2y is to the power of 3 equals to, we also do the same for this one, d dx of 3. So if I differentiate x is to the power of 3 with respect to x, what would that give us? That's 3x squared straight up. Because you have an simple one here, 3 times 1 is 3. You move on from here, that will give us x squared. Plus, now if you look at this function clearly, you notice that I have two things multiplying each other, x and 3x is multiplying y squared. So I'll call this 3x my u, that's product 2, and I'll call this one my v. So using product 3 in this case, I'll have it as uv prime plus vu prime as well. So I'll come back for that. Minus, can I differentiate this 2y cube with respect to x? No, that is invalid. You can't do that. It's not allowed. Okay, you can't differentiate 2y is power of 3 with respect, since there's no x to differentiate. So there's no way you can actually do that. But I'll just do a slight manipulation. But I can differentiate that 2y cube with respect to y, right? It's possible. Since I can see y to differentiate, I can create this thing with respect to y. But if I now ask you, is this expression equals to what I have up here? No, it is not the same. But how can I make it to be the same? It's actually until when I multiply it by dy, so that if this dy cancel dy, I'll just put over dx so that it's going to look alike. So if this dy cancel this dy, I'll still have the d dx of 2y cube, which is the same thing as what I have. So what I've just done here, what I've just written here, is still the same thing as what I have up here. So just light manipulation, that's how it works. So differentiate 3, if you differentiate a constant with respect to x, that's 0. Okay, so I have this as 3x squared plus, so I have a product 2 here, u. What is my u? U is 3x. U is 3x, right? So my v prime is differentiate y squared. If you want to differentiate y squared now, remember that you want to differentiate everything with respect to x, right? I want to differentiate, v prime means differentiate this y squared. Differentiate y squared with respect to x. Is it possible? No, it's not possible. But I can actually differentiate that y squared with respect to y, right? But this and this are not the same. So I have to multiply it by what? By dy over dx. I'm trying to show this step by step. Okay, solution for it. So the next thing for us to do is to go ahead and input that of v. My v is y squared. My u prime says differentiate 3x. If I differentiate 3x, that should give me just 3. If you differentiate 3x, there's an invisible 1 here. 1 times 3 is 3. Subtract 1 from here. That's x is power of 0. That is 1. 1 times 3 will give us 3. So I think that's all for that, for this bracket that I have here. Then minus, differentiate 2y cube with respect to y. That should give us 6y squared. Right? But I still have it multiplying dy over dx. Right? So then everything is equals to what? 0. So the next thing for us to do is write 3x squared there, then plus, you open a bracket, you have 3x. I want to differentiate y squared with respect to y. That should give us 2y. Differentiate y squared with respect to y, that's 2y. but I still have it multiplying dy over dx. 3 times y squared is 3y squared minus 6y squared dy over dx equals to 0. So therefore, the next thing for us to do now is to go ahead and write 3x squared there plus, open this one, multiply this one together, that should give us 6xy dy dx, then plus 3y squared, then minus 6y squared dy over dx equals to 0. So I feel what I have left here is just okay. I'll collect like terms. I'll take this dy dx and this one I have dy dx together. So that means if I take this and this together, I'll have it as what I've just written here on the screen, as you can see. This one here plus times this, I have it here. Then minus 6y squared dy dx equals to, now I want to take this 3x squared to the other side of the equation. Now I want to take this 3y squared to the other side of the equation. So if I take this to the other side, I'll have it as minus 3x squared. If I take this plus 3y squared to the other side, I'll have it as minus 3y squared. Okay? So what I notice now here is that I notice dy dx is common. So if dy over dx is common, what am I going to have left? Cancel this, I'll be left with 6xy. Minus cancel this, I'll be left with 6y squared. Then equals to minus 3x squared minus 3y squared. So what I notice now is that I have to divide both sides by this coefficient of 6xy. You know, we are looking for dy dx. So we divide both sides by 6xy minus 6y squared. So this one will cancel this one. So whatever I have to do now here is to just go ahead and find the common factor here. But let's quickly relate it with the option. I noticed they did not cancel anything. So you don't have to cancel anything here as well. So what I noticed here is that minus 3 is common. But do they factor? I think they factored out minus for every options. So minus 3 is common up here. So if minus 3 comes minus 3, I'll be left with s squared. Then, minus is common. Minus 3s squared cancel this minus 3. I have it as s squared. So if this minus 3y squared divide this common factor, that means minus will cancel minus. I'll be left with 3 cancel 3. I'll be left with plus y squared. Please take note. Now, if I open up this bracket again, I'll have this back. Minus 3 times s squared is minus 3s squared. If you had put minus here, that means you will get the wrong answer. But the correct thing here is going to be plus. Please take note. Now, and here, 6y is common down here. 6y is common. So if 6y is common, 6 and y will cancel. I'll be left with x, then with minus, and then 1y cancel out here. 6 also cancel. I'll be left with y. I think that's what we'll be left with. And that is option B. So option B is correct for that. So let's quickly move straight to the next question. Let me clear this off first. Let's clear this off. So then the next thing we have now is okay, it's question number 25, 26. So for question number 25 now, for question number 25, let me take a pen. I was given y is equals to exponential raised to the power of 1 plus x squared. Same thing, I've explained something like this in my previous video, which is for Mat102. Go and check that calculus video. I've explained something like this. If you want to differentiate what you have here, okay, obtain dy dx. Dy dx is just equals to differentiate what you have up here. That's the first thing you need to do. Differentiate what you have up there. What you have up here. So what would that give us? Differentiate 1, that is 0, plus differentiate x squared, that will give us 2x. Then you now repeat everything back. Simple as ABC, that's all. So you don't need to subtract 1 here. Just this is the final answer. That means if I ask to differentiate exponential raised to the power of 1, the first thing you need to do is to differentiate Noah first. Differentiate Noah and put your answer here. Then repeat e raised to the power of Noah back. So that's how to differentiate anything that looks like exponential of a function. Exponential function. So final answer here is just 2x times exponential raised to the power of 1 plus x squared. So this is the final answer here. So you see it's very easy. That's option. That is for option A. That is for option A. That's how it works. So let's quickly solve this question there, which says we have x squared plus y squared minus 25 equals to 0. is question number 26. We have x squared plus y squared minus 25 is equals to 0. So looking at this now, find the slope of the graph at x equals to 3 and y equals to 3. So if you want to find the slope, that means just find the y dx. I said it the last time that slope also means gradient and gradient also means the y dx. So if you can find the y dx from this expression, that means I will differentiate everything individually with respect to x. I've done something similar to that before. So this one too with respect to x of y squared, then this one with respect to x of 25. This one also with respect to x of 0. So if I differentiate this x squared now, that will give us 0. But can I differentiate y squared with respect to x? No, it's not possible. So let me just give you a shortcut. Is that you use that that my previous explanation. But I'll just advise you to take this. Just use this pattern. Anytime you differentiate y, or let me just say anytime you touch y and you differentiate it, always remember to multiply it with the y dx. Always remember. So I want to differentiate y now. So you see y is there. So I want to differentiate this y squared. That will give me 2y. But always remember to multiply it by what? The y dx. That's just the easiest way to quickly remember. Instead of you writing d dy first or y squared then times the y dx. But just have it in mind that anytime you want to differentiate y, always remember to put the y dx at the front. Always multiply by the y dx. So if I differentiate this 25, that's constant, that's 0. Differentiate 0, which is a constant, that's also 0. So looking at this now, dy over dx, 2y. Sorry, this is not 0. Sorry for that. What am I doing? Sorry for that. This is not 0. If I differentiate x squared, that's 2x now. If I differentiate x squared, that is 2x. Okay, sorry for that. So I have 2y dx. I want to take this 2x to the other side. So I have it as minus 2x. So divide both sides by 2y. By 2y. 2 cancel 2. I have it as minus x over y. So my gradient, dy dx, is also known as gradient and is also known as slope. And the final answer is minus x over y, right? So looking at this now, I was given x as 3, y is 3. So just go ahead and put, okay, x is 3, y is 3. So divide the 2, I have it as minus 1. I'll not lie to you, this is CBT question. I'm very sure of that. So instead of you going to all this yourself, just go ahead and divide this and put minus. But you have to solve it to be on the safer side. So minus 1 is correct for that question. So let's look at question number 27. For 27 now, given the demand function PQ, I have x is equals to p raised to the power of 3 minus 3p squared plus 200, where x is the number of items, blah blah blah. Find the rate of change of p. Find the rate of change of p. That's change in p. Okay, the p with respect to x over dx. That's what that's supposed to look for. This is what that's supposed to look for. So that means you are differentiating it implicitly. And how are you going to differentiate this one implicitly? You have x is equals to p raised to the power of 3 minus 3p squared plus 200. So I will just advise you, looking at this one now, this expression there simply means you are trying to differentiate x with respect to p. S is against p, right? So that means I'm differentiating everything, each of these terms with respect to p first. Okay? That means whatever I'm going to look for at the end of the day is dx over dp. So if I get my final answer down there, I'll just take the reciprocal to find it to get this dp over dx. So you are going to differentiate each of these terms with respect to p. Differentiate with respect to p. What are you differentiating? P is power of 3. Differentiate this one to with respect to p. That's 3p squared. Differentiate this one to with respect to p. 200. So remember that if I'm to differentiate x with respect to p, do you see p here to differentiate? No. You want to differentiate x with respect to, is that possible? No. Okay, anytime you touch x and you differentiate x, that will give us what? Remember to put the p over dx. I think that's the pattern we need to follow. No, that we remember to put dx over dp here, just like what we have done, just a change in sign. Okay, just like what I've done up here. Check it here. Okay, so that I'm differentiating with respect to x, right? To the down part. When I now go to this place, I want to differentiate y with respect to x. It's not allowed, right? I want to differentiate y squared with respect to x. That means there's no x to differentiate. So I'll go ahead and differentiate this one to y. Anytime you touch y and you differentiate y, always remember to put d of what I have here, d of that letter that I have inside this bracket with respect to what I have down there. So that means the same thing here. That means if I differentiate x, that's 1. So whatever I'm going to put here is d of what the letter I have here over what I have down here. So dx over dt. So differentiate p with respect to p, that's just 3p squared. I don't have any issue with that. Differentiate 3p squared, that's 6p. Differentiate 200, that's 0. So my dx over dp is just equals to 3p squared minus 6p. What I'm looking for is dp over dx. That's going to be, what I need to do, just drop and across multiply. Dx times 1 is dx. Dp times this one is 3p squared. I already know that the answer is 1 over. Okay, just the reciprocal, but I want to cross multiply so that you see it clearly. Dp. If someone multiply this one, this is what I'm going to have. So you divide both side by 3p squared minus 6p. 3p squared minus 6p. So my dp now is equals to dx over 3p squared minus 6p. So how will you get rid of this dx? Just multiply by 1 over dx on both sides. 1 over dx. So that if this dx cancel this dx, I have, I have 1 times dp, that's dp over dx here, equals to 1 over this, 1 over 3p squared minus 6p. So let's check whether this answer is in the option. So I have it here, see it here. 1 over 3p squared minus 6p. You know, 3p is common down there. When you look at this, 1 over, I notice that 3p is common to these two terms. So if 3p is common, 3p cancel 3p squared, that's, I'll be left with p. 6p divided by 3p, that's 2. So that's what I have left. Okay, so I have it as option D. So for question number 28, I gave you this as an assignment the last time. I believe you've done that, right? For that 28, it's not something that is really hard like that. I have minus 2. I have this point given, which is parallel to this. So let me write out the equation of the line, or the equation of that line first. So I'll make y the summate of the formula. That should be, I want to take this one like this, I want to bring this one like this. I have 3x minus 5 is equals to 2y. So divide both side by 2. So I'll have my y to be equals to 3x over 2. That's 3 over 2x minus 5 over 2. Whereby my gradient is 3 over 2. Since my gradient here is, if you get it to, if you relate it to it, y equals to ms plus c, that means my m is 3 over 2. Since my m is equals to 3 over 2, what are you going to do? So for parallel line, what is the condition? It says gradient 1 times gradient 2 must always be equals to positive 1. If it's for parallel. So what are you going to do from here? So the first gradient I got is just 3 over 2. Now let's get the second gradient for the parallel line. So that means I'll just multiply both sides by 2 over 3 to be on the safer side. That's faster. 2 cancel 2, 3 cancel 3. So my second gradient is equals to 2 over 3. Since I've gotten my second gradient, I'll just go ahead and use this point. I remember that my gradient is always equals to y minus y1 over x minus x1. So that means my m now is this m2, which is 2 over 3 for the parallel line, which is parallel to that line. So my y minus y1, this is our value for x1, this is our value for y1. My y1 is minus 3, so I'll put minus 3 here. X minus, my x1 is also minus 2. So if I solve this thing out, I will have something of this nature. I will have 2 over 3 is equals to y plus 3. Minus and minus is plus. And I will have x plus 2. Then cross multiply. That's 2 times x plus 2. 3 times this, that's 3 times y plus 3. So that's 2x plus 4 equals to 3y plus 3 times 3 is 9. So looking at this now, let's quickly make y the solid of the formula. I don't know what's going on there. Let's check. This is 3y, right? So let's take this like this. So I'll have 2x plus 4 minus 9 is equals to 3y, right? So 2x minus 5 is equals to 3y. So divide 2 by 3. So my y is equals to 2 over 3x minus 5. This is what I'm supposed to have as my final answer for that question. Yes. That means there is something wrong somewhere. I'm seeing the answer as 3 over 2x. Is that true? Minus 2 minus 3. Let's check. I have 3x minus 2y equals to 5. If this comes here, I have my gradient as 3 over 2, which is correct. So when I find the parallel line, the gradient for the parallel to that line, so I should have 3 over 2 here, which is 2 over 3. So is it that I've done any mistake here? M2 is 2 over 3 equals to y minus y1. That's y plus 3. And I have x plus 2. So 2 times x is 2x. 2 times 2 is 4. So there's no any mistake here. 3 times y is 3y and 3 times 3 is 9. There's no issue with that. So here in this case, you have 2x. I have 9 comes here, I have minus 5 equals to 3y. So I've not done anything wrong. Divide 2 by 3. Then I just have 2 over 3x minus 5. So there's issue with this question. Please take note. Okay, there's issue with that question. I'm supposed to have 2 over 3x. 2 over 3x minus 5. So there's something wrong with this question. There's something wrong somewhere. Please take note of this last question. Something wrong somewhere. Okay. So what's the next thing? Okay, let me just save this video for now. So the next video I'm going to explain now will be for solution from question number 29 to 50. So I'll drop that anytime soon. Thanks for watching.